Why do we need configuration? Why isn't an IP address enough? When the end device has an IP address, several questions are being asked. What is the network's exit point? Through which router do we exit the network? What is the DNS server's address that we need to reach in case we need to translate a domain to an address? For how long is our address? And if we're part of the network, then what is our network's subnet mask? Notice that following these questions, we can realize that we're not talking about obtaining one IP address, but obtaining a complete configuration. Why do we need Dynamic Host Configuration Protocol, or DHCP, for? The DHCP is used to configure the host. Host configuration. It's important that the configuration is dynamic. It means that we don't necessarily receive the same IP address every time we are connecting to the network. The host also has the option to ask for an extension of the configuration on the one hand, and on the other, to allow connection for temporary users. It's important to remember, when we're talking about a case in which an end device wants to connect to a network, it's possible it may have been connected to the network in the past. And it also may be a completely new network. Both situations require a simple and easy connection. A manual check of the required configuration takes a long time. If we start checking what the required configuration is, it will take us a long time to complete the connection. The DHCP server gives us the option. Why a DHCP server? Because it provides configuration services, is a simple connection to the network. The server can provide the right configuration, such as what will the IP address be and for how long, and also to allocate dynamic address to new users. When an end device connects to a network it's unfamiliar with, it cannot identify whether there is a DHCP server. So, what do we do when we don't know something? We ask. Who do we address the question to? To everyone, because we don't know anyone in the network. What is the question's purpose? To discover whether there's a local DHCP server. Therefore, the first message sent by the end device is DHCP discover, to find out whether the service exists. We can see that our IP address is distinct, because we don't yet have an IP address, and the destination address is special. Broadcast, because we want to ask everyone. In case the network has a DHCP server to receive the question, it will answer it. The server cannot answer the device that sent the question, as the device doesn't have an address yet. Therefore, the server replies to all devices connected to the network, and it offers a configuration. A network can have several DHCP servers. For example, to prevent the possibility that the servers crash and new devices will not be able to connect. When the server's reply, or replies, is received, the end device will ask for the configuration that was offered to it by one of the servers. The request is sent to all devices in the network, and it includes which configuration we want from the information we've received. The server sends confirmation for the configuration. The question is, why is the configuration limited in time? In a perfect world in which users end their network connection, or a moment before the computer is shut down, it sends a release message to the server in order to return its configuration. Just like renting something for a short period and returning it. In reality, it usually doesn't happen. For example, if the computer crashed or there's a software issue, there isn't an organized disconnection. Therefore, we need a balance. On the one hand, we'd want that configuration will not be for a short time, which leads to extension requests from the server, something that may cause it to overload. If we compare it to daily life, when somebody loans an object to someone else for several minutes, as the minutes pass, the loaner keeps asking for time extensions every few minutes. On the other hand, If the configuration is for an extended duration, the server would be less busy. The problem in this situation is that if stations don't notify release to the server, the network will have fewer IP addresses to allocate, because we're allocating addresses out of a group of addresses that we have. So, we need to maintain a balance between having short-term configurations and having long-term configurations. How are messages being transferred? The end device requests a configuration through the protocol. The traffic layer initiates UDP protocol because we don't have a defined device to connect to. We don't know the server, and we want to ask a question and have a quick answer. In that case, the UDP protocol encapsulates. It envelops the DHCP and transfers it to the network layer, where the IP protocol will repeat the same action. In the case of an IP address, the original address in our case is 0.0.0.0 because we don't have an address yet. And the destination address is broadcast 255.255.255.255. The encapsulation also takes place on the line layer. We shall add that each layer adds a protocol headline with the necessary parameters. For example, in UDP, we will add the ports unique to DHCP. The server performs the reverse process of de-encapsulation from the line layer to the network to the traffic, and the application layer within the DHCP service. The DHCP service receives the requests, acts accordingly, and responds.